This is a presentation of the 19th Annual Colorado Snow and Avalanche Workshop, a program of the Colorado Avalanche Information Center, Friends of CAIC, and the National Avalanche Center, presented by Demuth and Pomoka.
My name is Julie Demuth, and I'm a research scientist at the National Center for Atmospheric Research in Boulder, Colorado. And I'm really excited to be able to talk about some work that my colleagues and I are doing on extreme weather risk communication, perceptions, and responses. So as I get this going, my background is in both atmospheric science and communication. So obviously the work that I do is at the intersection of those two fields. And Ethan and Jason asked me to talk about this work, even though it's not specifically focused on avalanche research, to talk about some work that we're doing to look at risk communication in a field that's really parallel. And obviously that's the field of meteorology. And so as I get going, I think it's always useful to have a little bit of a foundation so that we're all working from the same place. And I want to talk about weather through the lens of risk analysis. First, by thinking about what do we even mean by the word risk? This is something that we talk about all the time, especially in the COVID era. And I've got a couple definitions here that define it as a possibility of an undesirable state of reality or negative effects that can occur due to natural events or human activities. Or more simplistically, it's just the possibility of harm due to an event. And so when we think about it this way, we recognize that, of course, extreme weather can cause harm. And so it's one kind of risk. The corollary of that then is, what do we mean by risk messages? Well, these are any kind of information, whether it's statements, pictures, signs, anything else that describe or talk about actions regarding the hazardous activity or how we manage the risk. And so, of course, then weather forecast information, outlooks, watches, warnings, anything else are a type of risk information. And the one other foundational thing, I think it's useful to think about risk perception. And this is a huge construct, but really by this we mean these are the judgments that people make about any of the events or situations or activities that could cause negative consequences or harm. And we make these judgments by collecting and interpreting signals. We're looking at information about the uncertain possibility of the event or the negative impacts that can occur from it. And after decades of research on risk perception, we know that it is very multidimensional. So there can be cognitive pieces and affective or emotional pieces. And even within that, there's a lot of different dimensions, including people's perceived exposure or likelihood of severity. Today, I'm really just going to focus on likelihood and severity, but I still think it's useful to know kind of what we mean more generally about by the phrase risk perception. So what I want to focus on today are tornadoes. And the reason that I picked this is partly because I'm from Nebraska, and so this was my first weather love, extreme weather love. But also, even though I don't study avalanche risk, I think that there probably are some similarities. So tornadoes are low likelihood, very high severity types of events. They're spatially localized, and in fact, the spatial variability of the risk is quite nuanced, but they're also rapid onset. And even though there is a lot of tremendous research in the weather community that's making great strides to understand tornadoes, there still are limitations about understanding whether they're going to occur, where they will occur, and how intense they're going to be. And I put a quote here from a couple of leading tornado researchers that describe tornadogenesis or the formation of tornadoes as a Goldilocks problem. You really need everything to be just right in order for it to happen. And so because we have these uncertainties, then that means that there's uncertainties about whether the tornado is going to occur, but those uncertainties, even if we don't explicitly recognize them, also are part of the risk message or the forecast message process. So then just a little bit more of a framework, and we'll dive into some research here. If we have risk messages like weather forecast information, we know that shapes how people perceive the risk and how they respond to some degree. But in order to develop more effective risk messages, it really does require us to understand how is it that people think about that information and how do they respond. And we need to do this in a more iterative fashion. It's not just that we create something, we put it out there and see what people think and what they do, but we have to understand what they think and do in order to better shape the risk messages that we create. And of course, this information here is really simplified. In reality, it's a lot more complicated than that, but we're going to work with this framework for today. And so the work that I and my colleagues do really can be categorized into two different threads of research on tornado risk messages. We do work where we are looking at how tornado risk information is currently conveyed. And in fact, I've listed here some details about a project where we studied a case study of 2 tornadoes that were deadly, killed about 15 people. We went in afterward and did these quick response interviews. We're also coupling that with data that we collected on Twitter from people who were in areas at risk of those tornadoes, because we were interested in seeing what risk information did they get, how did they perceive the risk, and how did they respond dynamically, because the threat doesn't just occur, but it actually evolves over space and time. And so we have this research that's ongoing. It's actually not what I'm going to talk about today, but I wanted to mention it in case anybody is interested and wants to ask me about it later. Well, what I am going to talk about is our other thread of research, where we're looking at the future of tornado risk messages and how can we start to study that now? Because of course there's a lot of work going on in the weather community to shape what weather forecast tornado risk messages are going to look like in the future. And specifically, I'm talking today about probabilistic tornado warnings. And so this is a project that several colleagues and I are working on, where we're looking at how probabilistic tornado warnings might shape people's risk perceptions and responses. And so the reason that we're doing this is because this is plausibly the future of tornado warnings. So currently, tornado warnings are binary. You're either in or outside of the polygon. And the implication then is that if you're in the polygon, there's an equal likelihood of a tornado occurring everywhere inside of that. But in reality, the likelihood of a tornado occurring inside that polygon is probably more nuanced than that. And with increasing understanding of tornado genesis, observations, and then also numerical weather prediction modeling, the weather community is better able to start to characterize this probability distribution and provide that more nuanced information. This isn't currently being provided to the public, but it is very much in the pipeline. And so what we're trying to do is understand how people might perceive and use this information so that we can guide how it gets disseminated in the future. And so there is a lot of work. Of course, weather forecasts are inherently uncertain. So there's a lot of work that shows that if we explicitly convey uncertain, it actually is useful. It can enhance the decisions that people make. It encourages trust, but you have to create the information in a way that really matches the decision at hand. And more specifically, in the context of tornado warnings, there has been some work that has looked at people's risk perceptions, but this has all been done in an experimental context, which is useful. But what we want to do is augment that experimental research with interviews of people who have experience with tornadoes so that we can understand how they're going to perceive and use this information in the real world context of their lives. So based on their beliefs, their sheltering options, their past experiences, and so forth. So diving into this is what we did for this research. We designed a few different tornado warning conditions. Today I'm going to talk about 3. The deterministic condition, which is on the left-hand side. So this is just the binary, you're either in or out, like it is currently conveyed today. We also had a red color probabilistic condition, which is what's there in the middle. And the colors are a little hard to see, but the different shades represent a 10%, 30, 50, 70, and 90% chance of a tornado occurring. And then we also had a numeric probabilistic condition, which is what's on the right here, which we presented as text, which conveyed the probability of the tornado hitting different locations. And we did it this way because we thought we would test how people might respond if this information were available, say, via your cell phone. We provided people with a scenario. I'm not going to read it all to you, but we told them that they were at home, it was a weekend, they were aware of a threat, and then that there was a tornado warning that they got on their cell phone that provided a lot of information. And we did this because this is the kind of information or context that people might have currently if they get a tornado warning, and we wanted to represent that as best as possible. So for each of those conditions, we placed people at different locations so that we could test how they responded based on different levels and areas in the warning. We had a 0% location outside the polygon, 10%, 30%, and 90%. And we did this for the red color and deterministic, and then similarly for that numeric probabilistic condition. And then what we did is we asked people the same question over and over. So we gathered data on people's risk perceptions, and here we really focused on 2 cognitive dimensions: their perceived likelihood, so what they think about the likelihood that a tornado will hit the location, and their perceived severity, so how much damage they think could be caused. And we asked these questions in a couple ways. We started with just an open-ended, what can you tell us? And then if they could say something, we had them mark a scale, and we did these in person so it was on paper. And we took where they marked on that scale and we converted it into quantitative data so that we could look at both their qualitative and quantitative information. And then we also asked people questions about their intended responses, what they would do if they were in their home. And we asked many other questions that I'm not going to have time to talk about today. We did these interviews in person. This was pre-COVID, about a year and a half ago in Alabama. And you can see the sample of 36 people and kind of the demographics of them. But what's really important here is that this wasn't a sample of people who have tornado experience. So everyone had some to a lot of experience taking action to protect themselves. And then 2/3 of people said that they had some to a lot of experiences with tornadoes firsthand. And this is what we wanted. We wanted to see how people who are used to seeing these warnings interpret and would use the information probabilistically. And so diving into the results, I'm going to first start talking about people's perceived likelihood. So what they could say about the likelihood that a tornado would hit their location. And I want to start first by looking at that quantitative data, so based on where they marked that scale. And what we did is we took where they marked it and we measured what proportion of the line that was, and we converted that to a perceived probability. And that's what I'm showing on this plot here. The y-axis is their perceived probability, and that x-axis is the underlying probability, or that different location that we put people at. And I'm showing the deterministic condition results here in black, red color in red, and the numeric results in the green. And just looking at this plot, there's a lot that you can glean already about what people think. So to step you through this, that numeric condition, numeric probabilistic condition, which is the green, we see that people's perceived likelihood on average is closest to the underlying probability, the probability that we told them. And the red color condition, where we also provided people probabilities, they systematically overestimate the likelihood. And they do so more at those 10% and 30% locations, less so at the 90%, probably somewhat shaped by how we were able to measure the ceiling on that scale. And then in the deterministic condition, we see that even if we're not explicitly telling people anything about the probability of a tornado hitting, they're inferring a distribution of a tornado hitting. And that distribution is highest near the center of the polygon, and it's lower on the edges, as you can see with that black line there. But relative to those probabilistic conditions, it's a relatively flat distribution. So these are the quantitative results. But it's interesting to dive more into the qualitative data to see how people talk about and how they reason about things. So how they reason about the deterministic condition. So on all of these slides, on the left-hand side in that kind of dark blue text, this is our characterization of the theme of what they said. And then in the blue boxes, these are the actual quotes. So a couple ways that people reason about the likelihood. They think a lot about they bring to bear their beliefs about the storm paths and the evolution of tornadoes. As you can see from the quotes here, person 18 says tornadoes pretty much follow the same path every time. Person 27 says, well, the tornado's pretty far away. It could change paths, which shapes how she thinks about the likelihood in the downstream part of the polygon. We also see people talk a lot about their limited predictability of tornadoes. And I love quote 22. This person says, the tornado could go anywhere. You can make a circle. You can never actually predict it. Some of the other ways that people reason, this person, number 15, talks about things that in a way that really reflects those quantitative results in the plot I showed before, where they think that the likelihood is much higher in the center and it's much lower on the edges. And then you have person number 20 here who talks about the trust in the originators of this information and how that shapes how they think about the likelihood. So this person says, for those professionals to even classify the area, the tornado warning polygon, there's a pretty good chance it's going to happen. That's enough for me to say that it's certain. So moving on to how people think about the likelihood in the red color condition, we see similar themes emerge, but now people take that additional probability information and that augments how they reason. So we see that people still talk about the storm paths and the evolution, as person number 1 talks about how tornadoes tend to follow the same path. But here she's focusing on that color and thinking about how if it propagates, it's going to be right on top of where she is. You again have people who think about the limited predictability. Person number 8 says, well, it says there's a 30% chance, but I mean, there's always a chance. I don't think anyone ever really knows because we've seen them take turns. So that probabilistic information shapes what they're thinking, but they still think that there's limited predictability. And then uniquely in this condition, we also see some people for whom the color connotes where the storm is at. So person number 3 says she thinks the likelihood is higher now that she knows where the tornado is. So she's really focusing on that dark red area as conveying to her where the tornado is located. And we see how people reason about the numeric condition. Remember, this is the one where their average likelihood was really similar to what we showed them, and that is borne out by how people talk about it. They think this information is pretty clear-cut and easy to understand. It's very straightforward, not really going to analyze it. It means what it says. It's a 30% chance, a 70% chance of not. So we also wanted to talk about how people think about the likelihood at that 0% location outside the polygon, because I didn't focus on this when I showed the results earlier, but in the deterministic condition, people still think the chance of a tornado occurring outside is about 20%, and in the red color condition, about 12%. And when people talk about this, they again talk about that limited predictability of tornadoes. Person number 3 who says, you never know when the winds are going to change and the tornado comes straight for you. But you also have people who really bring to bear their contextual knowledge, experientially derived knowledge about tornado threats. Person number 2 says, you're most likely in a tornado watch, even if you're not in the warning zone. Just because you're not in the warning doesn't mean you can't be affected. So this person knows that if there's a tornado warning in effect for one area, it probably means that there's a tornado watch over a larger area. So it means that they don't think that the chance of being hit by a tornado is truly actually 0. So moving on to people's perceived severity, we asked about how much damage people think could be caused. And the reason this is important is because The probabilistic warning information, all warning information, only conveys information about the chance that a tornado will occur, not how bad it will be. And so if people are confusing the two and there's a low chance conveyed, they might think that that means there's a low chance that there is going to be a lot of damage. And that's what we really wanted to ascertain. So we asked people this question, again, in the open-ended and marked scale. We also gave them the opportunity to tell us they couldn't tell us anything about severity. And in fact, a quarter of our sample said that they couldn't tell us something about severity. And they said so in different ways. That really reflected indirectly that they think that tornadoes can vary in the amount of damage that they can cause, as person number 33 is revealing. But several people also directly explained that the warning information doesn't tell them enough or anything about severity, as person number 9 says, where you can't tell damage from the chance of it hitting your location. So this is good, and this is really encouraging. But for the people who did say something about severity, we wanted to look into that a little bit more. And the way that we did this was by subtracting their perceptions of severity and likelihood from each other, taking an absolute difference, and then averaging that. And so it's a little confusing here, but basically a bigger difference between their perceived severity and likelihood means that they're less confused. It means that they were less likely to give similar scores for both. And so a smaller difference means they were more likely to respond similarly, which means they were more confused. And if we look at these results, we see that there's more conflation in that red color probabilistic condition, a little less in the numeric probabilistic, and then more in the deterministic, least in the deterministic condition. But when we look at the qualitative results, we actually get a little bit more to the story. So in fact, there were people who explicitly truly did conflate the information. So person number 1 says, well, if you're telling me there's a 10% chance, I think that maybe the rain and wind isn't going to be that strong. So they're really trying to say something about severity based on the likelihood, which is incorrect. But for everybody else, they're actually reasoning in more complex ways than this when they're thinking about the chance that there could be damage. And they're thinking about the natural and built environment. They're thinking about the preparedness level of the city or of different individuals as reflected by these quotes here. I'm not going to go through all of them. But that final one, interviewee number 2, who says, well, I don't think there would be that much damage because Tuscaloosa, which is the city, is pretty prepared. And in fact, they think that Tuscaloosa is more prepared in the wake of a big tornado that they had several years ago. So they're really drawing on that experience. And then just to wrap up, wanted to talk a little bit about people's intended responses to this different information. And I really wanted to focus on their responses at that 10% location, because this is an area where the probability of a tornado occurring isn't that high. So we wanted to see what people would do with this. And in fact, we saw that some people said that they would go ahead and seek shelter. Person 20 says, I'm going to believe the professionals. Again, that trust comes up, and I would seek shelter immediately. But then you had other people who didn't necessarily say that they were going to seek shelter, but they didn't say they were going to ignore the information either. Instead, they talk about being vigilant or paying attention to the weather and weather information, as person 17 and number 33 did indicate, where they said, I would be worried and listening to the weather, or I would be vigilant. I'd probably seek more information and keep a close eye on something. Then you also had people like person number 1 who would say that they would use this information to notify others who maybe are in higher chance locations. And in reality, we only had 2 people in our entire sample say that they would truly do nothing. And they both said this in response to that numeric probabilistic condition, that textual information, where this person, number 13, says, it wouldn't make me want to do anything because it's almost close to 0. So just to summarize, I think that it's important to realize that people are going to bring to bear their knowledge and beliefs when they're interpreting risk messages. I think we often feel like we want people to interpret the information at face value. And that almost never happens, and we see that that doesn't happen also in this context. So specifically thinking about tornadoes and tornado probabilities, people think about what they know or believe about storm motion and path or the unpredictability when they're thinking about the likelihood. And this is true even when we give them explicit tornado probabilities. When we think about severity, very few people are truly conflating the likelihood information as conveying severity, and so that's good. And instead, we see that they're reasoning in complex ways. So again, very sophisticated in their thinking. But then we also see that when we convey probabilities, when we compare that numeric and red color condition, that the color in the red color condition does further shape people's perceptions. We saw the different ways that that came out. And then finally, I think that we often have this idea, these normative beliefs about what people should do, that they should get some information, they should automatically take action, and they should take like that most desired action. What we see here is that even if people aren't seeking shelter at those low probability locations, they are using the information in other ways. So they're really taking the threat seriously. they're information seeking and information sharing. So very few people are actually ignoring the threat. And so with that, I want to go ahead and thank some folks here. Thank NOAA for the funds for this particular grant and share my email address. And I'll go ahead and stop presenting this and say that I'm very much looking forward to the panel on October 16th. Hopefully this presentation has provided some interesting information, some food for thought, and I'm eager to discuss. Thank you.